Okay, so we're on chapter 43. This is about animal behaviors.
When's our lab due?
Lab is due Thursday, before you go away for spring break, so I can grade them over spring break.
If the bug lab did, you're still using like the bug lab?
When do you want us to do ours?
Can we do ours?
You need to do it
Like
before Thursday, because it's due Thursday.
Okay.
you're gonna do it.
What were you asking?
Like me and Jonathan came up with
Like after
like
school
the projects to sit like together, but then he did it
Oh,
over
all right.
here. So
Did you get the
Jonathan-
stuff from him?
Okay, yeah.
Okay.
I'll do the procedure.
All right.
Okay.
Here are a couple of birds called lovebirds, and lovebirds have a behavior that they do. It's nest building. And this type of lovebird, the Fisher lovebird, carries nesting material in its beak. This type of lovebird, the peach-faced lovebird, carries the nesting material in its rear feathers. It tucks the nesting material into its rear feathers and flies off with it.
What kind of bird?
Peach-faced lovebird. This is on page 820.
Well, the Fisher lovebird has this in it.
Fisher lovebird has it in its beak.
Oh.
Peach-faced lovebird has it in its wing feathers.
How does it not fall out?
I don't know. Tucks it in there. The important thing here is that their behaviorists wanted to study if this was a genetic behavior. Is it a genetic behavior that they're born with, or is it something they learn from their parents? And one experiment they did to try and figure this out is they crossed the two of them together. They bred Fisher lovebirds with peach-faced lovebirds. And they watched what the babies did. And the babies tried to tuck it in like halfway. They didn't carry it in their beak, but they didn't carry it in their rear feathers. And they really couldn't carry it, and they couldn't build nests.
They all know.
Oh.
Well, I don't know if they let them die or if they fed them or what. I don't know. Maybe they just killed them themselves. I don't know. Scientists are mean. But anyway, the point of the experiment is that it seems that this behavior is genetic in some respects. That you are born with either carrying it in your mouth or tucking it in your feathers. That there's some genetic aspects to the behavior. And whether behavior is genetic or not is an old argument. You may have heard of it before.
Nature versus nurture.
Nature versus nurture. Ever heard that? Nature means what you're born with. Nurture means what you've learned. And a lot of experiments have been done that show that nature isn't more important and nurture isn't more important. It's about half and half. Half of what you know you learn, and then a lot of it is also what you're born with.
Did we do that in psychology?
In psychology, we study this exact same thing. Some of the stuff in this chapter is repeat from psychology.
Oh, cool.
Here are some snakes. The inland garter snake does not eat slugs.
Really?
The coastal garter snake does eat slugs. Why is that? Why does this have a behavior that this one doesn't? Well, when they graft tongue flicks per minute, which is how many tongue flicks the snake have. Now, why does the snake flick its tongue? Scientists now know that snakes flick their tongue because that's how they smell. It's like sniffing. It's like counting sniffs at a dog. And yeah, you sniff if you're trying to smell something.
But you sniff, you know.
Now, if you look, the inland garter snakes, when slugs are around, flick their tongue a lot less than the coastal garter snakes do. See, the coastal garter snakes are up around, looking around 4.5 flicks per minute, where the inland garter snakes are more around, 2 or less.
How do you do half a tongue flick?
You don't. This is an average.
Okay.
If you take 10 snakes and you count 15 total flicks, that's a 1.5 average. So, the point is that the Inland garter snakes are not smelling as much when the slugs are around because they can't smell slugs. And since they can't smell slugs, they don't eat slugs. So that's the basis of their behavior. It is genetic. If you can't smell them, you're not likely to be eating them.
Why?
Because they can't locate them.
So they
Can't find them.
So what should they eat?
Well, they use mostly smell.
If they see a slug,
Don't they have like thermovision?
They may not know it's food.
They see like by heat?
Some types of snakes do, but I don't know if these snakes do. Either way, they're not able to smell it. So that is genetic. What you're able to smell is genetic in nature. You're born with what you're able to smell. And so if you can't smell something, you're not going to eat as much of it as the next guy that can smell it. You see what I'm saying?
can't you not taste that?
That's true in humans. I don't know how it applies to snakes. Here is a mother mouse or rat, and it shows it on page 822. This is a mouse. It's a mouse, I guess. These are baby mice.
It's a louse.
And this mouse is taking care of its babies, and this one is not. This mouse has this certain gene called FOSB. And this mouse does not have that gene. So that gene must have something to do with caring for your kids. Because mice that don't have those genes present, they won't care for their kids. And mice that do have them present, they will care for their kids. And you can see this graph showing if the FOSB alleles are present, they go and get their pups. This is proportion of pups retrieved. If you spread the pups out in the cage, this mother will go get them, and this one will not. So that allele, that gene, has something to do with this behavior. So again, genes and behavior can go together. Your behavior is somewhat genetically programmed. Emery, are you getting this? What's going on there? You look like you're sleeping. There's a fish that they talk about, something called a stickleback. This is an example, though, of learned behavior, because behavior can also be learned. Here's a baby chick. And when it's born, it pecks at its mother's beak. And the mother will then puke into the mouth of the chick to feed it.
Does it swallow the food and then puke it up? Or
Yeah.
It's regurgitation.
It regurgitates it because it doesn't have hands to carry the
I
food.
thought they just left it in their mouth.
Yeah, they throw it up.
I thought that was always the
How do they do that?
They go. And the chicks love it. Now, here's the deal though. To tell the mother that the chick is hungry, the chick will peck at the mother's beak. And they charted pecking accuracy of chicks by putting a card with a beak on it and counting where the chicks pecked on the card. Chicks are kind of dumb. They peck at anything that's red. The newborns only hit on 3 out of 10 times, it looks like. But on 2 days old, look how accurate they are. In other words, they got better.
Right.
They learned. They're so good at this behavior because of learning. And that's the nurture side of it. Learning is the nurture side of behavior.
Like when you learn to speak, is that nurture?
That is nurture. Learning to speak is all nurture.
Well, isn't
You aren't born knowing how to speak.
But couldn't it also be nature because we're a very social species, right? You know, language goes back a long time.
Wanting to speak is the nature part, very
Yeah.
good. And learning the words is the nurture
part.
Yeah.
Oh, I see.
Wanting to peck at the beak is the nature part for the chick. And learning how to do it well is the nurture part for the chick. This is a guy, he's a very famous scientist And his name is slipping my mind right now.
Gosling.
No.
No.
Starts with a K. I can't remember. But anyway, he did some experiments on imprinting. Conrad Lorenz, thank you. And Lorenz's experiments showed that if the mother is present when the baby ducks or the baby geese hatch, they will imprint on the mother. And they will follow her around until they are grown up and fly away.
Like in Twilight.
Yeah. But if Conrad Lorenz is the one around when they hatch, they'll follow him around until they fly away, even if they're presented with their mother just a few minutes later. There is a strong bond that Lorenz called imprinting that babies do at a very young age.
What if they imprinted?
But it only works for geese. It doesn't work for all animals, but it works really well for geese. So they follow him around forever until they're old enough.
When like people go through like a really big like shock or something.
Yes.
Like people abduct them and they like get them back. Whoever they like see and like talk to first like is the only person they trust. Like if their family comes. Who's this?
I didn't know that.
Anybody who gets like abducted or something.
That's a psychological principle?
That's why like when they get like they take them and they find the person that's been gone for a long time.
This is like for adults too? Really? I haven't heard.
What about
it's like for really severe cases though.
Okay.
What about like twins experiments where they take identical twins and send them
from
yeah.
birth. Yeah, we do a lot of that. Talk about a lot of that in psychology.
What?
But those experiments also show that it's
Yeah.
about half nature, half nurture.
What if they imprint on like a dangerous like a
Yeah, he even showed that they would imprint on a red ball that he's rolling around with a stick from behind a screen, and that they will follow around that red ball. And of course, the red ball is not going to lead them to food. It's not going to protect them from anything. So that would be very dangerous for them, and they'd probably end up dying.
So like even though
So,
they're like
like-
natural enemies, they would still follow like a fox or something.
That's correct.
Oh, so
They
if,
follow
like,
anything that's present when they hatch.
so if someone kills their like parent, like their mother and stuff, they'll follow that.
They would.
And then
Most
they
likely
just
that
follow
thing would eat them.
Are you my mother?
There was a scientist named Pavlov, which you've probably heard of. We studied this in psychology. That did experimentation on dogs and salivation. And he would notice that when you brought a food dish in for the dog would salivate. One day he brought the food dish in without any food in it, and the dog still salivated. And he noted that the dog had learned that dish means food. And Pavlov called this learning by association. He would later ring a bell every time he brought out food for the dog. And he noticed that later, if you just rang the bell, even without the food, the dog would salivate.
Have you seen
The
that?
dog has learned to associate it, bell and food. Yeah, I've seen The Office. That's what you're going to ask me about. They they make a joke like that on The
So
Office.
that's like whenever you put on your
Why don't
shoes,
you
your
have
dog
those
walks, like
included?
gets
I
excited.
do. Hold on. What's that?
Like whenever you put on your shoes, your dog gets excited because he thinks you're gonna.
That's
walk.
right.
Yeah.
He's associated you putting on your shoes with you taking him outside. And they call this learning by association. And Pavlov's the famous experimenter that kind of discovered that.
Mm-hmm. I made a joke about that last week.
I'm not sure what the starling migratory experiment is.
Is that where they take like pigeons and drive around in a car and let them out and they find their way home?
They find their way back somehow.
Yeah.
There was I remember hearing a story about a dog who ran away from home and like 4 years later came back. Because it got lost, but then eventually it found its way.
I think my dog definitely knows where he lives. My
And
dog-
some of that's probably luck. I mean, there are probably a lot of dogs that get lost and never
Yeah.
find their way back. But
Yeah.
you can learn where you live and find your way back, and you learn smells that are familiar, and if you smell them, you can follow them back. So learning and genetics are important in behavior. So that's what this first section is about. Tonight you are to read page 43.1 and 43.2, the first two parts of that section. And I will show you the video here. If I have it. Office conditioning. Hey,
Damn, my file. I have to reboot again. Anyway, do you want an album? What do you think? In school, we learned about this scientist who trained dogs to salivate at the sound of the bell by feeding them whenever a bell rang.
We'll watch it next time.
Okay.